these photos is not famous. Hello, I'm Cihat, and today I'm going to talk about how I reinvented error handling in Swift. These photos were taken at Obj-C 2014, which I was very, very lucky to participate in because I won the Obj-C Student Scholarship back in 2014. And it was such a great year because actually Swift was announced that year. And I actually want to show you how it was announced. So let's play that.
What would it be like if we had Objective-C without the baggage of C? Well, we did more than think about it.
Yes.
We have a new programming language.
Oh, yes. What a crazy moment, right? So you can see my relationship to Swift has been with this day, starting with this day. And I was part of that crowd cheering and clapping, and I was so excited and fell in love with Swift right away. And I love Swift for its compile time safety and for the clarity and all the great things that we have in Swift. And I've been also following the Swift evolution, like development and all the proposals there. But there has always been one area in Swift that I have always been struggling with, and that's error handling in Swift. So what I will talk about today is first my issues with the error and the localized error types in Swift. Then I will redefine basically and show you my approach, how I would do it. And then we will also dive into type throws and what is good about them and what's not so good about them. And then try to find some ways that we can work with that. And at the end, I want to give you some tips for better debugging and user feedback. So let's get started. And I want to first answer the question, what is error handling even? And to do that, I want to show you a code example from one of my apps, LocalizedError. It currently supports string catalogs and you can localize them, but users have been asking for strings file support for whatever reason. They have some other build systems, but I've been working on this feature. So we have some simple type here, and we want to, this is a good use case for where we will actually see some issues and have to do some error handling. So we might start very simple and say, okay, we have to first load the file and read the strings file. And you can already see here that we are actually running into an issue. And issue because Swift actually gives us this. That's the strong part of Swift. The compiler tells us exactly we have a try keyword here. So you have to deal with that. And our function currently is not throwing. So this will not compile. What can we do? Well, the simple approach, we could just write a do catch around it and say, okay, we are dealing with the error now. But are we? First of all, this is not compiling even because the let contents is actually being called in the self.parse function down below, and it must be outside the do block. Otherwise, it will not compile. So we have to move that out. And then moving that out, we have to define the type, which is string. And then in the catch block also, we have to return our type because the function is returning a self type. So we can't just do nothing. So we might make that type now optional. And then we have a self optional, so legacy strings file optional, and return nil. You could say, okay, we have dealt with the error. But I would state that this is not error handling, this is error ignoring. And why? Because the error that we have in that catch block, we're not doing anything with it. And if we were dealing with that and handling that, we would have to do something with it, right? So we are just ignoring it and returning nil. And we even can look at this code that we just saw from a different perspective. This code, what you see now, is actually equivalent to what we just saw before. It's the same code, not the same code, but the same behavior. And that shows here we don't even have a do catch block. And that basically proves that we're not dealing with the error because we're not even having a do catch block anymore and has the same behavior. So what can we do here? Another thing we can do, very simple, is we can say, okay, we want to print the error. What do we print the error? Do we handle it now? Kind of. We are handling it now during debugging because during debugging, we can see the error in the console. But if we're not logging it, sending the file back to some server and stuff like that, we're not really getting anything from it. So I would say we're still not handling it. And that's basically only useful during debugging. So I call this error debugging. Let's continue. I want to cover why error handling is important as well. And there are two main reasons why we should do and we should care about error handling. The first is it makes debugging easier. We just saw this already. And it should be both in development and production. But also, it can improve our user experience in our apps. Why? Because if we tell the users what went wrong, they can maybe understand the issue and then find ways to fix it themselves. Or we could provide even call to actions right in our error messages, like try again or I don't know, whatever there might be. And then the user might know what they can do about it. Or for some specific errors that we know about, like some parsing issues or something like that, we might find a way to map the issue and fix it directly in code. So those are the three ways that users can profit from it. And when you do these things, this actually helps with user retention because users are going to be happier, and this can also reduce churn. The next one is, when should we throw errors ourselves? And we can look at this simple parse function, and I figured out that when I read some strings files, that sometimes there are import issues when people import xlib files in Xcode. That's like another localization format, and then something goes wrong. Or sometimes there are like // comments in strings files, which is an invalid syntax. So I figured these things happen, and I thought, okay, I should throw errors when I detect them in this function and make this function a throwing function. And this is exactly how you should use and should throw errors, because basically what happened is when I wrote the first version of the parser, I had some assumptions about the structure and all the details about what I expect there so I can work with that. And those held not to be always true. And so the key takeaway when to throw errors is always throw errors to communicate from the function that you have some unfulfilled assumptions. So whenever there's an assumption that doesn't hold true, you should communicate that. And returning nil doesn't communicate what happened wrong, what went wrong. Okay, let's get to defining error types, because we have to define them, and we usually do this with enums and Swift, and it can look something like this. And actually, this code already compiles. I just wrote an enum and said, okay, conform it to error, and it just built. So does that mean it works now? And when we like print this error and do something with it, it will have nice description and stuff like that? Let's take a look. The error type, oh, wait, it has no requirements at all. It's completely empty. So why? Is this just like a semantic type that we can tell this error system, like, you can throw this, but not really telling what happens then? I actually wanted to know, so I just wrote these enum cases and just threw them. And then I looked at, okay, what can we actually do with the error when I deal with it? And the autocompletion in Xcode only has this, localized description. So I go, okay, this is maybe the magic thing that error does, and it will just work. And it turns out that when we print this into console, this is the error message we get. The operation couldn't be completed. Translate kit, blah, 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 the type, and then error 0. What is that 0? It's the index of the enum case. So it knows there is an enum, it knows the enum case, but it just tells us the index. Why? Now, logging the error directly was my next idea. Maybe not localized description, but the entire error object or instance could work. So I printed that, and I felt like, okay, let's do that. And the output was like this. So now the print one gave us the case of the enum, but the other one, the logger one, gave us the full thing. This is like at least what I expected to happen, the type and the enum case. But the print one didn't do that. So I asked myself, okay, logger seems to work, the OS log logger. What happens when I show the text in UI? So I wrote some UI code. It's a simple Swift UI view, and we have some state, we have some texts, and then we have we are just assigning the error directly. And once I did the object, and once I did the localized description. And it turns out when we print the object, we get the case, and the localized description is still this not very useful thing that is going to be is getting printed. So what can we do? We could try to override localized description. That was my first idea because that's what I'm calling, right? So I wrote this code and I just gave my own text as feedback, as like return type for localized description. And then I just called the function again, and the UI looked like this, a déjà vu. Why? Again, the same thing. Why does my localized description not get called? I really asked this myself, and it's really interesting. It should work, right? And upon further investigation, I wanted to know, is the error that we get in the catch actually of the type that we throw? Or is there some type erasing or something like that happening? And so I tried to cast it. And when I casted it, I just did the UI thing again, and turns out this works. So it is the actual type I was throwing, but somehow the localized description didn't get called. And this is a bit complicated, but it has to do with how the things are done with protocols and also bridging with NS error. And I thought, okay, talking about NS error, what is NS error actually looking like? Can we throw that? We can actually throw that in Swift. We can write code like this. And then the way it works in NS error land is we have a user info dictionary. And in there, we have the NS localized description key. And that's where the localized description we had earlier is coming from, because it's been there in NS error. And when we print this in the UI, actually everything works. So you could say NS error, Objective-C. We should use that, not the Swift part. But of course, that's not what I want to do. And so my problems with error really are that the protocol itself is completely empty, has no requirements, and just a magic property. And it's not clear how to provide a custom message. It's like error prone. You saw I tried to override something I thought would work, but it didn't. And then the compiler behavior also doesn't help, because like what I expected to work didn't. And error is designed specifically for NS error compatibility. That is obvious to me, like when I investigate this further. So I thought to myself, hey, Cihat, why not use localized error? This is what Apple is recommending us to use. So I did that. And in fact, if you look at the code, this is exactly the same. I only changed the error at the top to localized error. And again, I expected some compiler error, but everything just built. I was again surprised. I was like, okay, maybe there is some magic there now. So I printed it, and another deja vu. Why? Why are we getting nothing again, or this weird case number? Let's look at the localized error protocol. It's actually defined with 4 different requirements. They're all optional, so like they're returning optional strings, which is already weird. And then there are 4 of them. And one is called failure reason and error description. What do we have to use? The type itself does not communicate that, so the compiler cannot help us. And this brought me back to the situation where Craig was saying, what would Objective-C look like without the C? So I would like to ask the question, what would error handling in Swift look like without Objective-C baggage? And I did more than think about it, and I have my own protocol for error. First, how should I name it? Well, protocols in Swift describe abilities like equatable, hashable, codable. And what we're doing here is we're throwing the errors that we have. So I named it Throwable. That seemed the most obvious to me. Then the Throwable protocol's implementation looked like this. I conform it to localized error to be compatible with all the existing systems. And I chose the name user-friendly message, which returns a string, is a required property, is not optional. And the name user-friendly, that part basically is the replacement for the localized. I don't know why they called it localized. Probably that we, as developers, know this could be user-facing, but many errors weren't actually localized, and the requirement was also string, not localized string or something like that. So I changed that to user-friendly. And the description part, and that's a learning for me in years of error handling, we don't just want to describe what happened, we also sometimes want to tell the user what to do about it or do some other things. So it's more an error message. That's why I called it user-friendly message. And there's no magic. It's that simple. This is the error type that I came up with. And I wonder why we don't have it yet, but now we have it. The next thing I want to talk about is type throws, like I said. And they were introduced in Swift 6, and the community had been asking for it for a long time. It allows us to specify the error type in a function and say exactly what we want to throw. It looks like this. Instead of throws, we can just write throws parsing error, and then we know what it can throw. And the compiler will actually fail if we throw something else. So it will actually help us, and that's what Swift should be about. In the catch block, because we know now the type of the thrown thing, we can actually switch case over the cases if we have the error type being an enum. So this is an example code, and this is the code from earlier. The only thing I changed is I added that throws there. So we now have a specific throwing type. Note that when we catch this error now, we can actually switch over the error, and we will even get auto-completion. And that's really, really amazing, because sometimes you just catch an error and you don't even know exactly what was thrown or something like that. But the compiler can tell you, okay, this could have been gone wrong. And you can start thinking, okay, can I handle this smartly somehow? And I actually did that in the comment format invalid, because it's easy to format the double forward slashes to some other format. So for the users, it was basically automatically fixed, and I just handled it in the catch. It was easy thanks to type throws. But type throws can also have a problem. So if we have a bit larger function here, you can see that down there inside this type throwing function, we are calling into a system API, which is the string contents of, and also the other function we have, which throws another error type. So the compiler will fail because it wants us to throw these read file error. And the other APIs are not throwing that necessarily. So what can we do? And when we try to handle this, we end up having an error type that has cases specifically for the other error types a function returning that error type might have inside. And this can be really, really annoying really fast. And even on the usage end, we have to now do the do catch. And what used to be 2 lines of code has now turned 12 lines of code. And that's also very ugly. And this is a very simple example. And you can imagine if you have like a big project with a lot of modules, UI, model layer, database layer, it can really, really become really big really quickly. And I call that error nesting hell. And we don't want to go into error nesting hell. So our type throws good now. The good thing is they're simple to switch case over. And they're easy to understand the assumptions made in functions. So whenever you look at it, you know exactly, okay, I just have to check that type. But it has a lot of boilerplate code that you need to write. And because of this, you're really making yourself slower and traversing a lot of code. And this is really not fun. And there's actually one more upside that we could have, and that's because in Swift, by default, the errors we throw and the messages we get are not really contextful. If you look at this error message that could be thrown, like no file exists at given path, you'll notice that it doesn't have any context of the read from file or anything else. So we don't know what caused this system error. It could be like down somewhere in some system library. And I'm in my app reading string files and string catalog files. So I want to know which one failed, and it doesn't give us this context. It's just saying no file exists. So, and it creates ambiguity. So my solution for this was to write another protocol. I call it the catching protocol, and it defines a static function, which is the way you define a protocol for an enum case. So if you want to have all enums to have a specific case like caught here, that's how you write it. And it's just that. It's very simple actually, but it kind of solves the problem because thanks to this now, we have the new error caught case. Thanks to this now, we can have a built-in default function in all errors that conform to catching that is just called catch. And this is read file error. You can see I can just call read file error.catch. So the error catches other errors, and you can throw anything inside there. It will just map it to the read file error caught enum case. And you can even see the contents type here, the contents variable doesn't have the type specified. So it can even work with implicit types. And this makes basically the 12 lines 2 lines again. It didn't fit the slide, but you can write this in 2 lines. So that's basically the catching type. And thanks to now a basically defined format, I could write a function call I called error chain description, which prints something like you see at the bottom there. You have a structure of read file error called legacy strings file error, and that was like the leaf node, and then you can even see the user-friendly message. If you had parameters, you would even see the parameters of the cases. So this goes like you can infinitely nest them, and if you have a really big structure, you will get all the nesting. And this is the really cool information that we need during debugging. All this code that I just showed you is open source in a package I called ErrorKit, and it's licensed with the MIT license, so you can use it. And it comes with a few extra features. You saw the error chain description I just talked about, but there is also a user-friendly message that is global. And what it does is, of course, if your type is conforming to throwing, it will throwable. It will basically use the user-friendly message from there. But if you have an NS error or if you have an localized error, it will automatically like figure out the right details that is available and conform a nice message. And that's the really powerful thing is it even tries to map known cryptic system error messages to better error messages and localizes them even. So how this works is again, there is another protocol in the ErrorKit framework. I called it Error Mapper. It has a static function, just also calls a user-friendly message. And I won't go into the details here, but basically the ErrorKit framework comes with 3 built-in error mappers that maps some known error cases, and the plan is to grow this over time. So if you come across some system error message that you think like, oh, this is cryptic, I don't know what this is, like an error code or something like that, and you figure out what that is, you can contribute it to the ErrorKit, and everyone in the community will profit from that. So there are more ErrorKit features. I will only mention them. There are 8 built-in error types for very common cases like validation error or database error. And also generic error. If you don't want to write a new error type, sometimes you're just quickly encoding, right? And there are 6 comprehensive doc.c articles, so you can read them to learn more about other aspects and all the things I talked about already. And a few more production-ready tools for debugging and user feedback. And one of them I want to show you because I figured out in my own indie apps that SwiftUI actually doesn't have a mail composer. You have to still go back to UIKit. And so I came up with a mail composer SwiftUI modifier that is really easy to use. You can just call isPresented to show it and pre-fill it with some data. And notice that you should, like that's my tip here, add device information as context. And even, and that's another feature of the ErrorKit framework, the log attachment when you're using the Apple Unified Logging System. If you're not using that yet, if you're doing print, you should definitely move on to OS log with Logger. And that will log it to like a file, basically. And Apple takes care of all of the details there. All you need to do is write like 10, 12 lines of code, which I did for you. So it becomes just one line of code, ErrorKit log attachment or log data and stuff like that. And if you want to adopt ErrorKit, here's an adoption path. You can pick and choose what you want. You don't have to use everything at once. You can start with Throwable and comply with user-friendly message. You can then consider also conforming to catching and using the error chain description. And you can add bug reports, like bug report buttons to your error dialog so users can directly reach out to you via email, for example. And you can, of course, also contribute back error messages that you find. You can even create your own error mappers if you're using third-party APIs that are basically also having sometimes cryptic messages, which we can't build into ErrorKit because we want to keep ErrorKit lean without any dependencies. So what are the key takeaways for you I want to share with you today from this talk? First, Throwable is a Swift native alternative to error. Throw errors to communicate assumptions. In all functions, if you do it everywhere, you will really profit from that and code will become more correct. And don't use nil and try in those cases. Like nil, for example, I personally only use when I have stored properties and things like that. The error context is also very crucial. So make sure you have the full story with the error chain description. And good error messages help both users and developers. Before I close, I want to show one more thing that I'm really always annoyed by. And you can see when we show error messages, sometimes we have something like this. You want to select the text when you see an error, and you want to be able to search for it. And sometimes in error messages, you might have like a link with a workaround, and you want to select it as a user and easily search for it. And I see many apps in some UIs not do that. And it's very simple to do in SwiftUI. So I just want to share this here today. Please implement this text selection API to make sure that all users are happy and no one really has a problem. So getting back to the photo from the start, I will for sure never get as famous as Craig Federighi is, but I hope that the throwable type will at least get as popular as the error type is right now. That's my hope. And I'm on Blue Sky if you want to follow me. My handle is always at Cihat, also on Mastodon and Twitter. And come say hi. And actually, I have these app cards. If you didn't get any of them yet, please make sure to grab them. And that's it for me. And thank you very much for listening.
All right, first question I have for you. So you mentioned returning user-friendly error messages with an emphasis on user-friendly. Do you have any good practice on what makes a good user-facing error that will be actionable and understood by the user?
Yeah, that's. I don't think there is like one answer to that, but generally speaking, think about the situation users might run into and also the developers users might run into. So the developer needs to know what happens in technical detail. So you have to have some hint at least to the technical stuff. And the user has to understand like what they can do. So if you, for example, have like if you look at the parsing, if I say like, hey, this field in this place is wrong, like if you imagine a JSON file and then I give them the JSON path, it's not really useful for the user, but it's very useful for the developer. So you might either do a balancing act and put basically a main user message there and maybe in braces something for the developer that might be useful, or you just focus fully on the user and leave the developer thing to the error chain description, which will have more details, and basically say I will basically send my logs to an analytics service or backend where I investigate that in a different way.
Yeah,
Cool.
my question was going to be next. What would you recommend for the developer side of things? And like you mentioned, give as much information as possible.
Yeah, we got a lot of questions from the audience. A bunch of them are sort of around like potential alternatives to using this or potential supplements. So one is that I actually had too was what about rethrows? What are the use cases for using that instead of this type of thing?
I don't quite understand the question. Like, the rethrowing is just throwing the errors that were there. You're not really changing anything there. So,
Yeah, I think it's I guess the question is like why would the main thing what's the main reason that you would use this instead of rethrows? Is it just basically to give more type information?
the whole idea behind this is that we have the error chain description. So we can basically have like this error call stack. So what I ran into oftentimes is, I mean, when we are debugging, we are looking at the function call stack, right? We're saying like, okay, this function is calling that function, is calling that function. And when a user reports an issue to me, and I just know like the leaf node and the leaf error, I don't know like which called which.
Yeah.
And that's the information I want to get there. And that's why this hierarchical system.
Yeah. Good answer. I think the next question is at what point would you use sort of result type with like the success and failure instead of just throwing the error?
Yeah, my first version of the slides, I had the result type as a topic covered as well. The point is, with I was working with the result type before we had type throws, and the result type actually is basically what type throws are doing for us when it comes to error handling. Because either something is successful and then you have the return type, or it's not successful and then you have the throwing type, and that's exactly what the result type does. But the Apple engineers, like on the Swift forums, don't really like the idea to using result as an like as a alternative for error handling, and that's just not what they built result as and for. So basically the answer is if you want to keep the result you can do that, but migrating to type throws is actually not that hard because it's the same idea in the API structure, but you might actually profit from it because over time Apple will support the type throw system and Apple engineers, but I don't think there will be much like convenience improvements to error handling with results.
Yeah. And then last question is have you thought about opening a proposal to introduce these protocols to the standard library?
I have. And in fact, I have some pitches on the Swift forums related to improving the result based error handling system. But I learned through that process that it's best to start with a Swift package to show like what works and what doesn't work, and what also the community likes and what they don't like. And when something gets popular, like the result type itself, the Swift evolution community will also pick it up and be more open to it. And then I'm also happy to make a proposal. I just need someone to tell me that they're open for this idea and not like waiting for the community to accept it first.
Makes sense.
So this is my first step to that, basically.
Step 1. All right. Any others? All right.
Good.
Thank you so much, Cihat.
Thank you.
You're welcome. Fantastic.